Okay, hi everyone. Now we need to go our lesson. Our lesson will continue for the tutorial 4.2. So for 3.4, sorry. So hopefully you are finished the tutorial. So now we go and check out the tutorial answer. Okay. Now I show you about the PowerPoint lah. So we're going to see the PowerPoint, is it okay or not? Because today raining, just raining, so I don't know the line is okay or not. Okay, so from here, please let's see now. Okay, a while we check first, got any problem or not. Okay, the others, can you see or not? Please PM me. Okay, I reload again. So the others, can you answer me through the Telegram? You can see my slide or not? Okay, 561. Got 3 is watching. Can you answer me? Sorry. Okay, I try to ask nobody to answer my question. Okay, Jasin here, is it Jasin? Okay, I off burst. I go to my screen. Okay, Jasin, can you see I live now? Okay, yes, Jihueni say yes. The others, okay or not? Yong Eun, can you see the live now? Can you see my photo? Yes, teacher. Okay, so I continue my lesson. Okay, got any problem? Please you all telegram me. Because here I cannot see your stream. I cannot see your chat. Later the chat I will see, because now I using the full screen. Okay, so I will start soon. So I check. Okay, the others please, you all just mention here lah. You just give me the name. You just comment your name here. So after that I can see what is that. Okay, so we start now. Okay, I play first. I can see your chatting. Okay, hopefully it's okay lah. Okay, the rotation. Okay. Okay, Justin, okay. Okay, so we start lah. So I turn back to the slide. Okay, so this one answer. Okay, now I show you the slideshow. Okay, the slideshow is about the answer of the tutorial 3.4. Okay, let's check it. So there's a question 1 until question 16. Okay, so this one's the answer. You check first. Got any problem, that means you can PM me. I also will help you to solve it lah, because before that got student ask me the question already. Melody got ask me some of the question, then Jasin also. So that means you still don't understand, that means you can PM me. Better you PM me, you snap the photo lah, because sometimes I'm not in the house, I don't know what's the question. You just tell me what's the number, actually I don't know. Okay, so this one is the answer. I want to go is a structure question. Okay, we're going to see the structure question. Okay, we see the any live chat here. Okay, so the structure question, question number 17. Okay, let's see the question 17. There's a diagram to show the transformer has a number of turns of the primary coil and secondary coil. Okay, primary coil is a 4,000 number of turns, and the secondary coil that's a 300. So we know this one is a step down transformer. Okay, step down transformer. Then we know the primary voltage, secondary voltage we still don't know. Okay, now explain how the output voltage is produced. Okay, remember, transformer working. How come the output voltage can be produced? So the first you must say you're using the alternating voltage. Okay, connect with the primary circuit. After that, when you just join with the primary circuit, you find it the alternating current will flow in. When it just flow in, what happens for soft iron core? Soft iron core will magnetize. Okay, after magnetize, what happens? They will produce a various of magnitude and direction. Then changing magnetic flux. After that, will pass through the secondary coil. Then the secondary coil will get the induced EMF. So this one is a process. How come the output voltage can be produced? Okay, let's see the answer here. Okay, when AC current flow through, or you say when you just apply with the AC voltage, then AC current flow through into the primary coil. Now the soft iron core is magnetized. You must say about magnetized. Okay, after magnetized, what happened? The magnetic field will link to the secondary coil. Okay, because of this one question may be short lah, just 2 marks. So you no need to say various of magnitude and direction. You just straightforward say changing magnetic flux. Okay, after that the link to the secondary coil. Then finally what happened? The induced EMF will produce at the secondary coil. So this one is how the producer output voltage. Okay, then we go to the second question is a calculation. 17. Okay, B. Calculate the output voltage. So they want to find the secondary voltage. So we're using the formula is the same. Vs over 240. Vs is a secondary. Then after that, this one must be Ns. Ns is 300. Then Np is a 4,000. So we find it. The answer is a 18 volt. 18 volt, is it logic or not? We're going to see is it step down. Okay, input 240. Then the output become 18 volt. So this one memang is a step down transformer. Okay, so this one is the output voltage. Okay, then we go to the next one. So if I go very fast, you go to stop me. I go see your live chat. Okay, then we go to the next one. Okay, this one. Okay, a lamp, 36 watt, 18 volt is connected across a secondary coil. Secondary coil, so that means we know this one lamp is the output lah, because they join with the secondary coil. Calculate the current in the secondary coil. Current in the secondary coil. So we're just using the power to calculate the secondary coil. P equal VI. So P now is a 36. V is a 18. So we find it. How many current pass through the bulb? So here, P equal VI. So we got 2 ampere. Secondary coil got 2 ampere current pass through. Then the secondary coil they join with the lamp, then light up. Now they ask about resistance of the filament bulb. Okay, resistance, remember V equal IR. That one is a Ohm's law. So you know the current is how many. Then you know the bulb voltage is how many. You also can do the calculation. If you do want using the 2 ampere, it's okay. You straightforward using the power and voltage. This one is more safe because the question already provided power and also voltage. Okay, so if you're using the power, suppose the formula is a P equal I squared R. Okay, I squared R. So from here, I show you the answer for current. Then this one is a resistance. Suppose the answer should be same like if your 2 ampere is correct. Okay, depend for yours because we got so many formula for the power. Okay, and also the energy cannot use because we do know the time. So from here, we just got V equal IR. Another one is a power. P equal I squared R. Okay, then next one. Okay, we go to the next part. Number 3. Number 3, they ask about the efficiency of the transformer when the current in the primary coil is 0.2 ampere. Okay, when the current in the primary coil is 0.2 ampere means you can find the input power is how many. Output power, just follow the bulb. Okay, output power is a 36. Input power, then you go to need to do the multiply. Okay, so from here, 36 is the output. Input is 240, go to multiply the current. P equal VI. So this one is a V, this one is a I for the primary. Then after I go to multiply with 100%, so you get it's a 75% is a efficiency for the light bulb. Okay, D, state two-way, how the energy loss in the transformer and suggest a way to reduce. So we just mentioned two only lah. We got so many, is it? We got resistance loss, okay, we got eddy current, after that we got hysteresis, and the last one is the leakage. So now the question they say two only, so you mention two, after that you give the two-way how to solve this one problem. Okay, the first one they say eddy current, so in the iron core. Okay, because the question never mentioned about the soft iron core or not. Okay, they never mention, so you can say just iron core lah. So later you say soft iron core also can. So from here we just say iron core, then can be reduced by laminate the iron core. This one is a eddy current. Okay, number two is a hysteresis. Using the soft iron core, finally they can easy to magnetize and also demagnetize. Okay, if you say leakage, that means you say you need to proper shape of the transformer. Then the secondary coil and the primary coil must widen closer. That one is a leakage, prevent the leakage of the magnetic field. Okay, if you say about the resistance, so you must say they're using the thicker copper wire, so it can reduce the resistance loss due to the length of the wire you use as a number of turn. Okay, so this one is a two-way. Now we go to question 18. Okay, question 18. They show you the three circuit, X, Z, and also the Y. Okay, I want you to see the input first. Let's check the input. Okay, input 3 circuit also is a 240 volt. Okay, number 2, we check about number of turn of the primary. 3 also is a 1200 turns. Okay, so that means the input all should be the same lah. If I ask about power input, then your answer for the 3 circuit must be the same. Okay, the next one, we're going to see the output. Output, number of turns, okay, is the same. 3 also is a 800 turns. Okay, but you see the power. Okay, the bulb also same, we got 3 bulb. Okay, but the power of the bulb is different. So you see the first one, the power of the bulb. Okay, arrangement first, we're going to see arrangement. The first one, the bulb arrangement is a series. The second one, the arrangement by the bottom one, the Z one is a parallel. The Y one is a mix. So from here, we can say about the how to count the power of the circuit. Okay, power, one more thing you need to remember. We don't need to see about the arrangement. We just plus. Plus together, that one we call total power. Okay, so first question, they want to calculate the output voltage of the transformer. So output voltage of the transformer, so we're still using the same formula. We want to find the Vs. Okay, either one enough already. You don't need to find X, Z, Y, no need. Just find one enough because everyone should be the same. Okay, so from here we show the calculation. Vs. Every circuit, the Vs must be 160 volt. Okay, 160 volt. Okay, now we need to find the input power. Input power also is 1 only. Okay, because every number of turn input and the primary input voltage is the same. So from here we find it, the input power P equal VI. Okay, so the problem here, we do know what is the I. Okay, what we need to do? Okay, we do know the I, is it? So from here, can we do the calculation? Okay, question got mention the I or not? I'm going to check first. Calculate the transformer, input power. Question got mentioned, okay, 0.2. Where my power hilang already? Okay, my question here, A. Then the B. B question hilang. So B1, B1, the question above, they got B to explanation. My B hilang already. So you're going to see the B. B is a 0.25A. 0.25 ampere flow through the primary coil. So that means I do the calculation. Okay, 240 multiply with the 0.25. Okay, input current the question got, refer the notes. So I get it, that's a 60 watt. Okay, 60 watt for the input. Okay, output we do not, because output every circuit is a different. Then we go and see the number 2. Okay, number 2, B, the question B is here, 0.2 ampere. Now we go to the B2, output power for the transformer. So I told you already, output power, we no need to do the series or parallel or another formula, no. We just plus. So you see the circuit X. Circuit X got 12 volt, 12 watt, then times 3. So become 36. Then how about the Y? Y you got 24 plus 24 become 48. And the last one is a Z. 18 times 3 become 54 watt. Okay, so this one is every circuit they produce a different power. Okay, then the input is the same, because your efficiency is a different one. Okay, depends for your arrangement. So now we're going to see the following. They ask you which of the circuit containing the transformer is the highest efficiency. Highest efficiency we know lah, the output power highest means you produce more of the output power, then there's the efficiency become highest. So from here your answer must be the circuit Z. Okay, then we give the reason because they produce the highest output power. That one is the reason. Okay, then we need to go the diagram 4.1. There's a one of the circuit. Okay, let's see this circuit. The charger connected to the 240 alternating current. Charger, okay, charger suppose we using should be the direct current. Okay, because you want to go to battery. Go to the computer. So battery charger contain the box X and Y. So that means charger inside sure got component to help to convert the alternating current to direct current, because your computer is using the direct current one. So that's why the charger, they help to convert the type of the current go into the computer. If you're using alternating current to your computer, actually they cannot function. So they might using DC. So we must got something component to help to convert the AC become the DC. Okay, let's see here. The function of the component in a box is to lower the voltage. Okay, first one, this one they want to lower the voltage. Can you see the number of turn? Okay, primary is more, secondary become less. So this thing actually is a transformer lah. What transformer? A step down transformer. Okay, another one, they say lower the voltage from 240 AC to 20 volt AC. Okay, this one is a function for the transformer. Okay, another one should be the Y, box Y. Okay, box Y actually they help to convert AC to DC. Okay, so this one convert AC to DC, suppose the component you not yet study. That's in the chapter 4 electronic. But later I will just introduce what is that. Okay, come, let's see the component X. We know there's a transformer. Then we also know there's a step down transformer. Okay, more detail a little bit, there's a step down. Okay, then we go to the next one. Explain why AC and not DC apply in the 4.1. Why using AC? Why we cannot using DC? So what you need to put, remember that sentence, DC produce constant magnitude and also direction. After that, do not changing magnetic flux to the secondary coil. So this one is a reason why we cannot using DC. Okay, let's see the explanation. Direct current voltage, they produce a constant magnitude and direction in a soft iron core. So therefore, changing magnetic flux there does not occur. So does not occur, what happens? No induced EMF will across the secondary coil. So this one is a reason why we're using the AC, cannot using direct current. Okay, now number 3, can you state the physics concept which explain how the component in a box X to work? Okay, box X just now we label already, there's a transformer, is it? So we're using what concept? Okay, remember I told you the concept is a topic name. The 3.3, the name of the subtopic. That's a electromagnetic induction. We're using electromagnetic induction. Okay, the next one. Okay, the efficiency of the component in the box X, okay, is 80%. They give you the efficiency. Calculate the input current when the output power is 65. Okay, input current we do know, but the input voltage we know already, is it 240. So from here, this one is output power. So your formula must be output over input multiply 100%. So from here, 65 is the output, 240 is the primary, then the primary current we don't know, multiply 100%, that's 80. So finally, I get it, the current passed through the primary coil, that's 0.338 ampere. Okay, then we go to the last one. There is a problem solving. Okay, essay question. Okay, let's see the problem solving. Okay, there's a connector to the 240 volt of the AC power supply. Okay, AC power supply. Modification has to be making the transformer so that the transformer can be used and the efficiency for 6 volt. 6 volt. 240 volt, make it become 6 volt. So the first step you must know, you need to using step down transformer. After that, become the mobile phone charger. Okay, actually our handphone is using the direct current. So the charger inside must put some component to help to convert the alternating current. Okay, now you need to suggest the modification to make the transformer based on the aspect following. Okay, let's see the aspect following is what? First one, 6 volt output. I want 6 volt output. So understood, you must say you're using the step down transformer. Why? Because I want to reduce the output voltage. Okay, number 2, can produce a steady direct current. This one is one of the things I want to show you later. I want convert AC become DC. Okay, number 3 is a high efficiency. Number 1 and number 2 actually just 4 marks only. So number 3 is 6 mark. 6 mark means you need to give the 3 of the factor how to increase the efficiency. Okay, let's see the diagram. They mention soft iron core. So you cannot mention soft iron core again. So that means the hysteresis point out cannot use. You just can left 3 more. You just can use that one only. Okay, then we start with the question number 1. Okay, step down transformer. Okay, the aspect step down transformer. The reason? Because I want to reduce the output voltage. Okay, now we go to the number 2. Okay, steady current. From the AC goes direct current. So they say apply the 4 diodes to arrange a bridge rectifier. I want to show you what is the diodes, what is the bridge rectifier. Okay. Okay, we see the explanation first. Because of this one arrangement, they can convert the AC to DC current. Okay, now we see how to convert. Okay, I want you to concentrate this diagram. Okay, I'm using the highlight pen. Okay, the first part, this one is a transformer circuit joined with the 4 diodes. This one is a diodes. Okay, now I want to label first. Which part should be the positive? Okay, I label first. Triangle, this part is a positive, this one is a negative. This one negative, positive, positive, negative. Okay, now we go and see the current how to flow. Because we're using AC, AC suppose is flow in opposite direction for every half cycle, is it? So from here we need to start the first round. We're going to set the first round where they need to go first. Okay, now we're going to check what color, the blue. Okay, the first one. Okay, if the current you start here. Okay, you start here. Okay, when I until this part, what happened? When I until this junction. Okay, when they until this junction, they must go to positive because you start with the positive here first. Okay, up. Okay, negative you cannot go, so we go to positive. That means the first round you go number 4. Okay, you follow the green arrow, the green color arrow. You go to number 4. Okay, after you go to number 4, can you see a junction again? Okay, when you see the junction, actually they cannot go back to the negative lah. Because negative here is a negative already, you want to come back to negative. So if cannot. So that means you follow the green arrow, then you continue to move. Okay, now in the circuit, we got one of the load. Load, that means inside got resistance. So now how you pass through the load? You go down. Okay, you go down until you go to this part, then you turn to the right, then you up. Okay, I want to mention this one. This one actually is not linked. Wire and wire never link. They just overlap. Okay, the transformer circuit you put at the down. This one, diode circuit one, you put above. So actually separate wire. Okay, when I move up until this part. Okay, some you ask, both also positive, where you want to go? Okay, I cannot go back to the number 1. Why? If I go back to number 1 means I go back to my original position. Cannot. If you start from here, you must end another side. You start from P, then you must end from the Q. If you start from Q, you must end at the P. So this one we call one complete oscillation. So from here until this part, where I need to go? I need to find number 2. I need to find the number 2. After find the number 2, then I come down, then I go to this part. This part is below the line of the diodes. So when I go here, I go up. Then I continue to up. Then I go back to the transformer again. So this one we call first round. So that means 4 we go to find the load. Okay, find the load first. After that 4 we'll go to find the number 2. Then we find number 2. Then finish one cycle. Okay, now we need to go to the second cycle. Okay, let's see the second cycle. Wait, I want to change the color. Second cycle. Lama. Okay, second cycle we start from the opposite direction. So that means I start from this part. Where's my point? Okay, I start from here. Okay, if I start from here means now the circuit is in opposite already. Okay, when I go to this junction, 2 and 3 junction, where I need to go? I must go 3. 2 cannot go, there's a reverse. So when I go to 3, then I continue until center again. The junction again, where I need to go. So for this one junction, I cannot go back to the original position, is it? Because you see negative also cannot in what? Negative, negative, I cannot crash together. So this one negative must be go another side. Then also pass the resistance. This one is a load. How they pass? Blue color and red color actually is the same direction. Means now the current pass through the load. Then the load, this one will join with the, they will join with CRO. CRO means just like the TV, small TV, they want to see the wave pattern. Okay? Cathode ray oscilloscope. So from here, every time the current, I don't care you from the top or from the bottom. When I go to the resistance, can you see always same direction? Always is from the up, come down, up, come down. We don't have any current is from the bottom go up. No, so must be come down. Okay, now when I go to the load, what happened? Okay, I go up. Okay, when I go up, where I need to go? Okay, can I say I go to number 2 and come back to this direction? Actually, it cannot. You start from here, you must end another side. So when you come to this junction, now you need to turn. Go to number 1. Then after that, balik, go back to your home. Okay? So from here, we need to mention, okay, we start with the number 2 first. Is it 2? Oh no, that's a number, yeah, we go to the 2, 1 number. Okay, sorry, number 3 first. Okay, we go to the number 3. I'm going to find my eraser. Okay, eraser. So that means I need to find out the first round. Just now it's a 4 load and also number 2. So this one I start with the 3 lah. So when red color, when it just come down, they go to the number 3. So we mentioned here there's a number 3. Okay, after number 3, they must go to find the load. When they find the load, the direction always same, go downwards. Then they go to the load. Okay, after go to the load, what happened? They come back, then go to the number 1. Okay, they go to the number 1. Okay, what happened this one? Okay, we go to number 1. Okay, so this one is what I want to explain about the diodes. So finally, let's see the CRO. CRO, there's a reading you want to show. Finally, what's the current they produce? The current produced is a direct current. Why? Because every time the current pass through the load is a one direction. So that means I can, from the transformer AC current, when I put the 4 diodes inside the charger, they can convert become direct current. Okay, so this one we will more detail go to the explain about this one circuit in the electronic topics. So now I just want to introduce first. Okay, how the flow of the current. Finally, I just want to detect the current from the resistance. So from the resistance, I get it, there's a direct current. Okay, so from here we continue with our number 3, high efficiency. How to make the efficiency become high? First one, laminate the iron core. Reason, can reduce the eddy current. Okay, the next one, use the thick copper wire. Why using the thick copper wire? Can reduce the resistance. Okay, the last one, winding the secondary and primary coil on the top to each other. Okay, up also top, down also is a top after each other. Then why they need to do like this? Because they want to reduce the leakage of the magnetic flux. Okay, understand? So this one is a essay question. Okay, so our lesson just until this one lah. Okay, hopefully you will understand what I'm talking about. Okay, I want to show you so everyone, okay or not? If you don't understand, that means you can PM me. What is that? Okay, I will see what time is it. We until what time? We until 1. Okay, see timetable first. Until 2:10. So I want to show you one short things only. So you wait a while. I go to open first. Okay, I don't know where I keep it. I go to file out first. Okay, desktop. File out the desktop. Okay, wait a while. I go to find the question to let you to see how to solve it. Okay, so you have read about the school rules, is it? When you come back to school, what you need to do? Please, you go to read properly. Every way also different when you move. Recess, when you go to school, then when you go to toilet, every map they will show you there. So make sure you follow the map. Don't jalan salah then kena saman. Okay, I want to show is 4.2. Okay, so this one. Okay, I show here. Okay, I go to slideshow first. No, this one. Wait, where the paper? I cannot find the paper. Okay, this one. Okay, I off. Then I on this one. Okay. I need to see this question. Okay. Go to slideshow. Wait I cannot find it. I want to change about the slide. So attendance here. So make sure you follow the instruction. I think go toilet you also take the don't know what pass lah. 2 person only. Okay, one toilet can enter 2 person only. So make sure you jalan berhati-hati lah. Okay, I just can inform you like this. The rest I don't know. Okay, because I also not yet go back to school. We just meeting for yesterday. So this one is the information they just tell the teacher. So everyone must be wear the mask lah. Okay, I found already. So I show you one of the question. So this question you need to answer in the chatting box. Okay, I go to slideshow. Okay, so this one is a diagram. Okay, there's a 1.4. They show you the design of the central heating system. They use in the cool country to heat and also keep the houses become warm. Okay, let's see here. They just like the heater lah. They want to make become warm. Okay, so from here they want you, they got radiator. Okay, radiator they want to cool down. Okay, they got boiler. Okay, heat energy taken in from the boiler. Okay, after that the heat energy given out from the radiator. Okay, then they pass. Okay, this one is just like your refrigerator lah. Okay, now we need to answer is this one. Suggest and explain how to build the house central heating system which can function efficiently based on the following aspect. Okay, first one they ask about specific heat capacity of the liquid. Okay, the liquid you want to put in to cool down. Okay, then what liquid you want to use? How about the specific heat? Okay, number 2 about the boiling point of the liquid. Boiling point of the liquid. Liquid go in actually for what? They want to cool down the radiator. So this one is a liquid. Okay, properties of the material they use for the liquid, the transmission, the pipe. What properties? What material we need to use? Okay, then the last one is the size of the fan you use to blow the heat from the radiator. You want to blow the heat out. Okay, so from here, actually here got 4, is it? So you need to add the extra one. Extra one normally we add at the material lah. Be easy to answer. Okay, so I want to ask the first one. Liquid specific heat capacity. So please answer. Okay, I check now. What type of the liquid you want to use? How about the specific heat capacity of the liquid? High or low? Then give me the explanation. Okay, anybody here can be answer? Okay, just type here what type of the specific heat capacity of the liquid you want to use. Water, high specific heat capacity. Okay, for the Song Ho Boon. Okay, now reason, you give me the reason why you want the high specific capacity. Okay, can be higher specific heat. That one is what? STPRE is what? More heat energy. Okay, can absorb more heat energy. Okay, can be absorb more heat energy. Okay, now I want the store more heat energy. Okay, so number 2 about the boiling point of the liquid. What you think about the boiling point of the liquid? High or low? Can transfer more heat. Okay, good. Then how about the boiling? Now we go to the second one, boiling. boiling point. Okay, high specific capacity, the liquid can be stored more heat and absorb heat well. Okay, good. Okay, now we go to second already. That's the boiling point of the liquid. Continue on, you just continue. Boiling point. Okay, high boiling point does not boil easily. Yeah, correct. Or you said does the temperature does not increase faster. So that one is a high boiling point. Okay, so this one is normally about the boiling point lah. Okay, number 3. Properties of the material. I want you to give 2 things. Song Ho Boon, okay, high boiling point. Okay, the liquid not easily to be evaporate. Also correct. Okay, then we go to the properties of the material of the liquid transmission pipe. So material, normally we using what material? Okay, you must mention the material is a Vian talking what? Okay, Vian just come in. Okay, what material you want to use? Okay, normally we using what material? Okay, strong material does not break easily. Okay, yeah, but I said 2 marks. Is it this one? Okay, 1 more marks. You said strong material already. Okay, another one. Last longer also can, strong material. Okay, suppose you can say, okay, last longer already. Another explanation, maybe you say does not break easily lah. Okay, some more got information about the material we need to use. For the transmission pipe, you know, PVC, normally we don't mention the name. Don't mention actually what is that. You cannot say, oh, I want aluminium lah, I want copper lah. We don't mention. Okay, you can mention that one is just now you mentioned this strong material. Okay, some more. You can using the high specific heat capacity of the material. That means they're not easy to heat up. Okay, not easy to heat up. Heat insulator, yeah, correct. Heat insulator. But heat insulator, you must say they can tahan heat lah, cannot melt lah. You say the something is a very bad material that also will melting. So from here you can say the high melting point. Okay, do not melt easily. Okay, do not conduct the heat. Heat insulator prevent the heat loss. Why to prevent the heat loss? Okay, this one is a transmission pipe, you know. Transmission pipe, you want to bring the liquid to go out. Okay, you want to bring the liquid to go out. You cannot say prevent the heat loss. That means you want do not melt easily. Maybe the pipe you can withstand the high temperature of the liquid. So each one cannot give prevent heat loss. Okay, we memang want the heat to loss. Okay, then we go to the last one. Size of the fan used to blow the heat from the radiator. We want to blow the heat to go out. So the size must be, every time I see the person is the same. Jiaxin lah, Ho Boon lah, Jianing lah, Yi Zhen lah. Asun, where to go, Asun? Okay, big size. Okay, big size, what's the reason? Ernest, wow, Ernest just appear. Hello, Ernest, I want to complete already. Oh. Big size, okay, yeah, big size. You give me the reason why big size. Achio never in, is it? More wind can be produced. For what? The wind you want to go where? That means you want to bring more heat to come out. Okay? Because you from the radiator, they say from the radiator. So that means you want to release more heat to come out. Okay? So bigger fan, heat can be removed faster. Yes, can. Okay, remove faster. You also can say more heat can be remove. Okay, cool down more water. What mean cool down more water? Okay, cool down the engine, not cool down the water lah. We don't want cool down water. Water memang is hot already, you cannot cool down anyway. Okay, sewage. Okay, baru masuk. Ayo. A long time never see the tree already. Tree, is it still follow our lesson or not lah? Tree where to go already Okay, so I will show the answer. Let's see together. Okay, high specific heat capacity for the liquid, able transfer more heat, absorb more heat. Okay, boiling point must be high, not easily to vapor, become the vapor, or you say evaporate. Okay, not easy to boil. Okay, if we use a big fan, the water easy to evaporate. Then the water evaporate already, what to do? No need to use already lor. So we do want the water to evaporate also. Okay, the water to come out, you want faster the wind, the hot gas to come out. Okay, we do want evaporate, cannot mention evaporate. Okay, then the low rate rusting of the material. You see, this one can put the low rate rusting. Okay, that means you want to prevent the rusting, that can last longer. Then you say the strong material, not easily to break. Or you say the high melting point material, do not melt easily. Okay, the size must be big, blow large amount of the heat. Okay, no sewage. Okay, no, hilang way. Sri hilang way. Okay, Sharon. Free. Okay, so from here, total here is 10 marks. Okay, this one is an essay question without any PQRS. This one is a question number 9 and question number 10. Okay, our lesson just until here only. I give you the exercise, this one only. So the coming soon must be the 3.5. Okay, I want to complete the 3.5. So this one is the final one. Okay, 3.5 I want to complete. I don't know can complete or not, because the next week I think the Wednesday you go to school already, is it? So we just got one lesson. That is Tuesday. Tuesday one lesson. Maybe I start 3.5 tutorial we discuss in the school lah. The school, I think they will separate the 5 size 1A and 5 size 2B. Got A, got B. Okay, so now show you again. So the coming soon, we see you on Wednesday lah. I do know the timetable. Wait, they come out the timetable. Then we go and see when I need to see your class. Then your class will separate by A and also B. Follow alphabet. Okay, follow the alphabet. So hopefully you understand what I'm talking about. So do know, just snap the photo for the question, then you PM me. Okay, I will answer you through the Telegram. So okay, thank you everybody. Thank you for your watching. Okay, bye. See you soon.